Hi, it's Gadget UK here again, back with an Amiga 1200. So this is my 1200. You can see it's got bits of dust and fluff and stuff on it. It's been in the back room, this, in the shade, for approximately 12 months. And can you see it's gone yellow? It has yellowed just from being in the shade. This was pretty pristine, I would say, for the most part, since I did it. And I did this back in 2008ish, I think. It may have been 2007, I don't know, sometime around then. So it took a long time to start to yellow again, but as soon as it's gone into a dark area for 12 months, it started to yellow. So I do think the yellowing, in many instances, is when these things go back into a dark environment. You know, they go into storage or into an attic or something. Because the thing is, and it makes sense if you think about it, a lot of these weren't yellow back in the day. When you owned one of these back in the 90s, I am pretty sure when you finished playing with it and moved on to a PC or a console or something, and this went to storage, it wasn't yellow at that point in time. But 10, 20 years in the loft, and they came out looking yellow. That is what the issue is. I think what I'll probably end up doing with this, once I've repaired this within this video, and we're going to recap it as well, that's the purpose of this. I've got a colour problem I want to look at, I want to recap it and just have an inspection of the board and see if anything needs doing to this. Yeah, after I've done that, I'm going to go stick it out in the sun, actually. It's nice and sunny today. I'll stick it in the garden for a bit, and we'll just see if we can get it to come back to a sort of normaler colour. It may be that I have to retro-bright it again. I'm not sure I can be bothered, to be honest. It was an awful lot of effort to retro-bright this when I first got it, and it really needed it because it was uneven. The keys were uneven. The case had like patches here, like a key overlay had been stuck over here, and it's like white in patches and yellow in others and stuff, and it just looked terrible. But do you know what? That, as things stand now, yes, it's a bit yellowed, very yellow actually, in the sunlight here, but it's linear, so you know what, I can live with it if it doesn't improve. So I'll start by disconnecting my accelerator. So this is the one that I upgraded in a previous video. You can see I fitted a socket there for the 68020, and I fitted a 25 megahertz part, and then I bodged a crystal on here, and we changed the clock divider to get 33. I think that's the most you could get out of this without changing the RAM. I think you could fit, in theory, faster RAM that would allow it to go to 40 megahertz. I think. I don't think you can push it to 50. Yeah, they're always pretty stiff, this, you can see. I mean, it's been in there a long time, but I'm having to use the CPU to, there you go, pull it out carefully and just pull it across. Let's just disconnect that. You can see I used a very fine wire here to join to a switch, which I have coming out the back. Now the switches on this were already installed on this 1200, so I kind of repurposed one of them. How does that come out there now? There we go, like that. So yeah, one thing you've got to be careful on these, and I think I damaged this in the past, and I may have shown and talked about that in the video. See that cap there? Those can get knocked off really easily on the edges here when you're inserting and removing it, and there's a couple up here, but there's a bigger ones in the further in, but there is a little one there, and in any case it was that one that broke off when I took it out to upgrade it. That just sheared off, the solder paste gave way. Anyway, it's looking nice and tidy. That you can see I did a good job of that. I think I used the old Weller desoldering station to remove the old CPU actually. Anyway, let's put that somewhere safe. So I'm pretty sure this has not got a full set of its original screws. It has got the original ones for the mount on the drive. So that screw's not very good. I remember that as not being a good screw. Anyway, I'm not going to bore you with the entire removal of all the screws here. I'm just showing you those are the main three. Now I do have a new case that was donated by Cathers, I think. So I could in theory swap the case out. But I'll be honest, I quite like this original one, even if that is yellowed. So yeah, but we could swap it in future. You can see I've got a couple of switches here on that little replaceable thing there. One to switch between 26 megahertz and 33. In fact, I'm not sure it toggles between those exact frequencies now. Yeah, it's looking really yellowed actually as it gets brighter in here today. And we'll just like hinge it at the back there and then just kind of lift and pull away from the back, I think. There we go. Yeah, and it's very obvious how this has yellowed now, just looking at it compared to the inside colour plastics and things, So let's just carefully have a look under there. Yeah, it's a bit bodgy in here. Look at this tape here. I don't know why that's there like that, so we can clean all of this stuff up while we're in here. I have literally not been in this since around 2008. Let's just try and see if we can lift that up. I don't like disconnecting these, they're a pain in the blooming. Let me just see if I can somehow lift this. It's like you really got to remove, there you go, you've got to remove the blooming shielding before you can get the blooming thing off. See, like that side there, I can't even get to it. I can't even get to it because of the shield. It's making me sad going in here just because of how neglected this system is at the moment. You know, it's gone yellow, it looks crusty in here, there's bits of insulation tape. There we go, pull it, how's it up? Do the same there. Up, I nearly pulled it off. Yeah, this flat flex has also suffered from the wear issue. It was being trimmed in the past by a very small amount, but anyway, that seems alright. Let's carefully pull the keyboard out. Yeah, you can see I pulled the top of the housing completely off there, look. So we're going to have to stick that back down later. So there are not many screws holding this in. Again, they're probably third-party screws. They're probably not the original ones. And it really annoys me when people lose the screws when they go in these systems. That bit of yellow plastic there, I'm not sure whether that's a stock thing, whether some of them had it, whether none of them had it, or what. But I've always left it in there, and it's kind of always helped just to protect down here from the shielding. So I don't know, have you ever seen one of those before in yours? And you can see when I've been in here in the past, I haven't bent these things back down because they just snap off. You know, the more times you take them off and remove them and stuff, and bend them back down, they'll break off. So we'll remove the IDE here. Just kind of lift it up on one side and then the other. Let's get that off. So yeah, I do need to deal with this because that looks crusty there. It's not something I've done, but you know, it was like that when I got it, is the point I'm trying to make. It's one of those dual ones, so this is why there's one of the switches on the back there. You can switch between them and have two different boot drives. Right, we can't actually remove that until we remove the drive now. So again, it's got a crazy screw down here that I don't think would be the original screw. Let's get that out. Then the drive should come out. Let's just disconnect it here. It's very dusty in here though, it does need a clean, but it's no wonder, because as I say, I ain't been in here for ages. So the case and the keyboard are having a sunbathe outside. And that's just reminded me of something funny. One of the guys in Discord was telling us about his retro brighting endeavours. It was a few months ago, might have even been last year actually, and he was doing his retro bright of one of his Amigas, and he had all the keys all laid out on a tray in his garden with you know, H202 and stuff on them, and then a seagull came down and stole one of his function keys. I think it flew off with it in its mouth, and it was never to be seen again. So if you're retro brighting in your garden, yeah, just be careful. You don't want birds stealing your keys. So let's just try and lift the shield in. I think they should all come up as one piece actually, and it's not, and as I say, nothing's stopping it from coming up other than a little bit of friction. Oh, there's one here, look, I must have just left one folded over. Let's just try and bend that up. And of course you could ditch the shielding, and that's probably the best thing to do because you're going to aid temperature. You know, it's not going to get as hot as it without the shielding on there. Let's get rid of that cable, we don't need it just now, and we'll get rid of that one as well. I don't remember it being this hard to get to pieces. It's probably one of those where it's easier when you get the board out like that. Let's just take the whole board out. And again, don't be working on the carpet. I'm going to go over to the mat in a minute and we get this out of its shield. Why is that side there not coming up? What on earth is holding that on? Oh my goodness. Yeah, I should leave that over there just to get that off. Is that coming out? Why is that not coming up? There we go. Interesting thing this has still got here is this little clip. These often lose that. And then the shield comes off, thank goodness. So, there we go. Behold, what revision is it? I honestly don't know. It's actually 2B. It's a 2B. So you can see it's looking very dusty here where dust's cut in through the gaps in the case and stuff. So it's the dark green PCB this. Some of the other ones were lighter than this, I'm sure. I'm just looking around the caps. I'm not really seeing any major problems. You can see the solder point there doesn't look so clever, so that one's probably started to leak, and that's usually what happens with these. But if you look at the solder points on the others around here, maybe that one as well, I don't know, it looks a bit dull down there, can you see that? but they're not too bad actually. Anyway, we will recap it. I've got a nice polymer set again around here, but again there's lots of dust here, so it could just be dusty. Yeah, there's no signs of any damage or anything there. It looks fine, but this has got a colour problem, which I'll show you in a minute. We'll connect this up, I think, before I do anything else to this, and I'll just show you what's happening. We're getting like a pink tinge. So I'm having to hold the camera up here. It's so bright in here today. Can you see? Look at the floppy drive. I'm not sure how well it's coming out on the camera, because from the LCD viewfinder it looks normal actually, but there's like a pink tinge. Everything kind of looks pinky. It's very hard to capture with that amount of light bloom. So I tell you what, it's a strange feeling working on your own board like this. You know, I mean, this is something I've got a lot of nostalgia for. I've used an awful lot. It's very dusty. It's sad to see it in the conditions at the moment. But I'm kind of apprehensive, because it's just served me so well, this machine. You know, and it's kind of, you know, the caps are kind of virgin caps, aren't they? You know, the original caps. It's not been touched, this board, at all. Unless the colour issue is something to do with something someone's done previously. That's possible, because the guy I got this from, I think he'd done a mod to make it work with accelerator cards. Yeah, and the colour's been a problem ever since I got it. I just never investigated it. I think the reason being is when I connected this up to my computer, you know, I used that little GBS thing, what's it called? 8220, an upscaler, and of course with that you've got 3 pots, red, green and blue, and I just tweaked the red one. Never thought anything about it, and that's how I've always used it, but clearly the red is too strong. Anyway, I got this lovely cap kit from Retro Bench. These guys are no longer around, unfortunately. They might make a comeback though, so don't just assume the time while you're watching this that this company doesn't exist. Have a look, hit eBay, they might be still selling, but yeah, as of early 2021 here, they're no longer selling these cap kits. And you can see I got a really nice kit here from them, which contains some polymer caps. Look at that. So polymers are fine to use in terms of aluminium replacements. Some more there, look. And those might be as well, I'm not sure. I'm not sure how many of them are polymer and how many of them are aluminium. But they are a good substitute, and that's what electronic manufacturers use these days, manufacturing PC motherboards, because they're so much more reliable in terms of temperature and you know, long-term usage. Look, those are as well. Nice polymer ones, very nice. So we'll get all these on here. We've got a replacement tantalum for the one on the DAC back there as well. Yeah, like those just look like aluminium ones to me, I think. So they're not all polymer, are they? There's going to be some limitations to the size and, you know, whether you can get the exact right capacitance in the same package. But anyway, that's what we're going to fit. So I'm going to start by just dusting over this with some cotton buds and stuff and IPA. We'll get it out of its shield. It should literally just lift up out of this. Hang on, the thing I always forget. You can see back here, you get this thing here that sometimes comes unclipped from the modulator there, look. Anyway, we can put that back on when we put it back together. But we need to remove all these blooming hex nuts from here. Oh, joy. Why they couldn't have had cutouts for those, I don't know. Anyway, I'll report back in about half an hour when I've got them all out. Right, that should now come out of the shield. And I think the next thing I'm going to do is just start cleaning up here with cotton buds and IPA. You could hoover that down first of all. You know, I'm sort of tempted to do that, but when you use a hoover on a PCB, you can generate static electricity. I mean, I've done it thousands of times in the past, never had a problem, but you know, ESD damage can be, what's the word? It's compounded, isn't it? It's like you do a small amount, nothing actually sees any issue, you know, you don't actually have a problem. But then you damage it again, you don't see any problem. But when you damage it a few times with ESD, then you get a fault. Something fails somewhere. Or something that has been damaged with ESD can then die over a period of time. Anyway, we'll just clean it up this way. Look, you can see it's very dusty there. I'll get the toothbrush onto it in a minute and we'll brush this down. So the only obvious thing I can see that's been done to this, can you see here? There's like something brown here. Solid, like solder, but it looks like it's kind of bridging over here. So I'm going to get some flux and desolder braid and try and clean that up. I don't know what's happened there. That is really weird. I can't see how that would be related to the colour problem, but it needs cleaning up. Beyond that, I can't see anything else having been done to the underside of this. We've got a strange large blob of solder there, look. That's a bit weird as well, so yeah, I'll reflow that. Let's just get rid of that now, I think. On the PCMCIA slot. I need to add some flux to that. Anyway, I'll report back in a sec. So I've added some flux to both of those points there. Let's try this one. Let's see what's going on here. Yeah, that's good enough, look. I don't know what that is. That's just a bit of solder. I'm going to reflow that as well while we're here. I have no idea what's happened there, though. Maybe someone's removed that in some really weird way with a different type of solder, like plumber's solder or something. I don't know, because it looked a really weird colour. But that looks alright now. Let's try that one. Let's just reflow that. Yeah, there we go. Got the excess off there. So I'll just clean away the flux there, and I'll continue to inspect around, see if I see anything else. So I've tested a number of things, checked the diodes here for the clamping, checked the caps, the resistors and things back here, and these ferrite beads. Everything around there is okay. I can show you some of that stuff later as we sort of summarise at the end. Measured the comp signal, 3.6 volts roughly. The VRF is 1.2 volts. So I don't see any issues. One or two of the caps have leaked. That one there has definitely leaked. So I'm going to just recap this and then see what it's like after a recap. But my instinct is telling me there's probably one bit on this DAC here that is kind of always on, given a red, on the red channel, given a red tint. So we might need to swap that out. If I do that, I'll remove it and I'll put a socket. Could be quite tight fitting a socket here, but I think I can just about do it. Might need to move this component down a little bit here, maybe this one up a little bit, but I think there's enough clearance around there. I want the socket because if it ever fails again, I don't want to keep taking it off and on, off and on. I do have a DAC spare. I'm not sure it's the right one. It might not be a VP101. It could be the ADV101. We'll soon find out. Anyway, I'll start by just marking the tops of these just so I know which ones I have still to do. And I'll go through them a range of times. So I'll start with the 100s. And over the years I've been using this, I did periodically check it and the caps did look alright. But the last time I did it was about, I don't know, 2 years ago. Yeah, that one there I think is leaked, so I'm getting quite large blobs of solder into a few places here. I'm not that bothered. It'll just make them easier to get off. You just got to be careful you don't get solder anywhere when you remove the old cap. Anyway, let's just do all of these ones around here. And bear in mind these through holes are going to get a little bit melted when I do this here, but the through hole ones I'll be swapping out as well. Yeah, that one's leaked. So I'm just going to go through and remove all of these ones here actually. And then I'll finish off with the through holes. This, here you go, the Antex is still heating up. There you go, that's one. Just move it out of the way. That's two. Oh, hang on. Stuck that to something then, I'm not sure what. Right, let's do that one. And I'm just going to shift these out of the way at this stage actually. Yeah, so with this one here, you might want to get some Captain tape there, but I'm going to squeeze into the cap. I don't mind if I melt the cap here. And that should allow us to get it off. Oh. Yeah, there we go. So again, I don't think that one had leaked. Yeah, and these ones here, again, I'm going to melt this cap here. I don't care, because we're going to replace it. You should remove the through holes first, perhaps. There we go. That one had leaked. Again, I'm going to melt this can of this cap here. I don't care, because we're going to replace it. That's that one off. And I'm going to get this one in here without touching the IDE. And that's that one off. So at this stage I'm going to switch the anesty on. I'm going to remove these 4 through holes as well actually. So whilst that's heating up, I will just clean up these pads here. We'll get the solder off. There's a lot of solder there, but I did add a lot of solder, so it's no wonder. I'm going to clean those pads up anyway, even though there was never a cap fitted there. You could fit one, it's just a bit of additional smoothing, I think. So I might do that, because I think the kit is going to have the cap for that position, just in case you've got the revisioner board that does have it. I'll check to see exactly where it is first before I commit to fitting a cap, but I think it'll just be a bit of extra smoothing. And let's just have a bit of a clean. So let's just add a little bit of fresh solder to these cap positions. It'll just make it easier to remove. This has got flux in it as well. So that's one. There's two here. Where's the other one? Ah, the other one's here. That's really beefy ground rail there, so that one's going to be fun. Although the anesthete should manage that okay, I'm sure. So let's have a go at soldering that. There we go. Yeah, that cap's come out, look, dead easy. So let's just have a clean around there after having removed those two. That hole there's going to be a pain to unblock. If these caps around here leak really badly, these little components here, they're like little inductors. I think they've got a cap in there or something, and a ferrous core and stuff, but it's just like a little inductor that are used for the encoder circuit here. There's like a couple of bandpass filters or something there. So yeah, if those get corroded, it's kind of game over. You need to try and find a replacement component or wire your own. You could take them to pieces and try and rewire them. Very fiddly to do though. Yeah, there we go. It's not looking too bad. So I'll show you one or two of these. Very difficult to do and fill. I'm going to get on the pad here like that, and then introduce the solder. A crazy amount. There we go. I don't know if you saw that did flow, but you can see that side for sure. I'll just get onto the pad and add some solder, remove the solder from the tip, and then just bob in and out. You may need to add a bit of flux if it looks like a funny shape. Let's just add a little bit more. There we go. That looks okay. I'm doing these before I do the through holes, because obviously the through holes will obscure access to these. So yeah, and I'm working this way across here, and then we'll do these ones. So this one's the first of the polymers. I'm going to do this side first, just because it's the easier one to anchor. There we go. And that just makes it much easier, so I can be careful coming in. Obviously Captain tape would help avoid risk here, but you know what, I'm not going to touch it, am I? There's enough clearance there, look. And then we'll just try and remove the excess like that. Yeah, that's not too bad. Quite large solder points on that one, but it's smaller than the original physical cap that was there. You know, the can size is a bit smaller. Anyway, I've cleaned around these ones with cotton buds. We'll do that one in a minute when I've done these two here. So that's that area recapped. I think I've got these polymers on the right way. I'm pretty sure the line indicates the negative on those, just like it does on other caps. Yeah, I hope so. There's nothing in the kit that indicates it's not, but I've never fitted polymers before myself, just seen them on PC motherboards used an awful lot. So all we have left now are the ones around here. These won't take long at all. These will be a pain to do, so I'll get lots of Captain tape around all these things before I start trying to get those off, but I'll get them all off in one batch again. Again, I'll try and show removal of one or two of these. See, that was pretty easy. And again, these two hopefully should be pretty easy. If you just kind of twist a little bit, you'll see it'll start to, not putting pressure, just when it gets to temperature, look, it starts to rotate off. So look, one side's moving, one not. Yeah, that one's off. So with this one here, you can see I got a bit of solder on that diode. I'm going to need to clean that up in a minute. I can certainly get the big iron like that there, and then I'm just going to risk it for a biscuit, I think, with this iron, and just hold on the inside of the cap like that. That is really hanging on. There we go. That stinks, that had leaked. However, with this one here, I am going to get some Captain tape on because I will melt that. Now, if you saw my 32-bit repair-a-thon series, where I covered 4 of these A1200s, you'll note that these are easy to melt, and what I suggested was multiple layers here, not 2 but 4, because the heat still transfers through, especially when you're wrestling with that cap, trying to get the blooming thing off. The thing that makes this difficult, obviously, is trying to get the Captain tape there, but leave that solder point there exposed. Let's just get another piece of Captain tape down there. And on this one, I'm also going to get a little bit down here. I'll try and push it like this round there. It's not that important, but and a final small piece down here now. There we go. And let's try and get this off. So I'm using the fine iron here. I'm coming in at this angle, pressing into the cap like that, and I'm going to use the chunky iron down here and totally obscure the shot probably. See, that is hanging on for its dear life. Come on. Yeah, there we go. I'm going to leave that Captain tape there while I fit the other caps. Anyway, let's get those all out of the way. I can't get a better angle on that, so you can't see the soldering on this side, but we'll do this side first because this is the easy side to solder. Let's just add some solder to the pad. Just press the cap down and reflow it, because what you tend to find happens, the solder goes underneath and it kind of lifts it up and it floats a little bit. So yeah, anyway, and then this side I can go straight down here. I'm going to obstruct the camera while I do this. I think I'm actually leaning on the camera in order to do this. Point there. Yeah, there we go. And if we had a tiny little bit of flux around there, it should reflow a little bit better. Yeah, well, there we go. That's looking much better. Yeah, that one's very difficult to get to. I think it would have been better if I'd have Captain taped off the port here. We just literally just touched it there, but yeah, no damage. So incredibly difficult that one was. Just squash my cotton bud right down here, and then I can get it into that gap there. Yeah, that's not too bad, that one. So onto this really difficult one next, and get our cap into position. I've resized it a little bit, that'll do. So carefully pull that off. Yeah, it looks alright, I haven't melted it. So let's get this polymer on. It's got blueprint on the band again. Just checking I got that the right way. Yeah, the square side goes to the square side on the silk screen. Let's get the iron in there, a little bit of solder, press it down, reflow it. You feel it sink a bit when you do that. It does float up with the solder when you only got one side soldered. And just rotating the board around a little bit. It's not quite as aligned on that pad, but it's fairly straight, so I'm not going to let that bother me. We'll just get a little bit of solder on that side. Wait, that's way too much there. Sometimes on these I'm using the Antex because it's got a better shaped tip and you just get a better flow look. So just that 10 to do and 222s. So that's it, we're all done with the recapping. So I'll just clean up the flux off each of the ones I've not cleaned here, and then we'll just go test it to make sure it's still working. I don't expect the colour problem to have changed. I think that's going to need a new DAC actually. You see, I'm not sure there are resistors in between the Lisa connections and the DAC like there are on the 4000. I'll check that, there may well be. If there are, you never know, we could have looked at it, could be a bad resistor or something somewhere. So all connected up, I made sure it was booting okay. The colour problem is still there. Yeah, as you can see, I mean the camcorder's kind of doing some sort of colour correction or something. It's like the grey. This here is supposed to be grey, and it looks great on the camcorder LCD, but actually it's pink to my eyes. So yeah, we've still got a colour problem. Let me just load something else, put Pinball Illusions on or something. Just to test out the audio. Why am I not hearing any audio? Yeah, the RCA phono jacks are not very good. I need to clean up the back of that. Can you hear that? It's kind of gone intermittent. But yeah, that's looking too pink. So the audio was just cutting out there. We did this exact same thing on an A1200 I covered in a previous video. Stick a link above to that, but yeah, because there was something else with that as well. It was some bad connectivity, but we'll just clean around this with the fiberglass pen initially. It's not too bad there, just a bit of oxidisation at the top, and obviously into the underside and the sides of this as well. And get a little bit of deoxit, the last bit of this tube, look. There's barely anything in it. Just enough to do this, I think. And just have a clean around. We'll try and squeeze that in there, but the point that makes a connection is usually right at the inside of the back of it, so that usually won't help. Best thing to do is get some onto the actual RCA phono connectors and plug them in and out a number of times. Anyway, let's try that, see if the sound's any better. Yeah, the audio issue has been solved by just cleaning those up. Onto this red issue now. I'm going to go and look at the schematics, I think, just to see if there are any resistors. I don't think there are. I think... Oh, the audio's gone again. So I'm going to go look at the schematics now to see if I can work out what this red problem might be other than the DAC. So I was following the clamping circuit and trying to work out if there's anything gone wrong around the area where it goes to the composite side here, you know, the video encoder, or, you know, the direct RGB output, what they had in common. And with the composite, it's like purple. Instead of a black screen, we get a purple screen. So it's more noticeable, the problem here, than it is on the RGB, which led me to think there's something going on with it where it goes into the video encoder. I think it's the video encoder side of things. And I followed that, I'll show you on the other side in a minute, the red, green and blue signals out of the DAC. There's the clamping network there. There are some differences on the green, but I think it's because the sync is merged with the green. Nevertheless, the three come out on this side here. I'll zoom you in a minute. So I've zoomed you in a tiny bit there. If we measure the resistance of these caps here, so this is one of the colours, look at that, 4 point something meg. This is another colour, 4.2 meg again, and here's the other colour, 8.45k. So this is coupling the signal, I think. So that is a problem. We've got some resistance there instead of it actually coupling it. I'm just going to go and take this over to the mat. I'm going to take it off, measure it. If it's a resistor, then that's the issue. But then I'm going to swap them around and see if the colour changes. But I suspect before we do that, it's probably going to measure as a resistor. I'm hoping anyway. So let's go give that a try. Now, you never know. Maybe I'm wrong here. Maybe I'm looking at the wrong components. I don't think I am. I'm pretty sure. I highlighted the red, green and blue out on the DAC, and these were flagged up as linked, you know, coupling components. So I think they're coupling, they might not be actually. It may just be part of a filter or something, but anyway, this one's measuring with resistance. Let's remove it and see if it measures as a resistor off the board. I might need to order some caps in if this is a fault, because I'm not sure I'm going to have the exact size here. Of course, I could just use the iron rather than the hot air, but the other possibility is this is alright and it's whatever's connected to this. There we go. So I've got that off, it's on the mat. I'm just going to let that cool. I'm tempted to measure across there now and see if there's a resistance still. Well, this is a weird one. You can just about see the meter there. Now I've removed it. The resistance is gone. It's in the region of mega ohms. These ones changed value, obviously because of the temperature there. Yeah, so the problem from that respect has gone. But this is weird because if I measure the cap we've just took off, hang on, let me show you. Oh, you can see it's going up. It's like it's charging. So that is not a resistor. I wonder if the hot air has done something to it, like it was faulty and heating it has fixed it, or it had a conductive film on it or something. And it's going down now, so I don't know. That's really weird, isn't it? You saw we did have 8K there. Now we don't. Well, believe it or not, I'm thinking that's fixed it. Now I've got some wavy lines come down here. The composite's awful. That's fixed it. That has fixed it. Can you see this is cream here? The disc is white. Now that's composite, but before composite was as purple as this when you first switch it on. So the red was being messed up. Yeah, that's fixed it. Right, let's get RGB. I'm so happy because I've not had to swap the DAC out. And you know what? Anything to avoid swapping the DAC is good news. It's hard to believe how hard that was to find. Seriously, because I've checked everything. It's the last thing I ended up at before considering swapping the DAC, and I was very, very close to removing the DAC. I bet that's quite a rare fault, to be honest. I also wonder if that cap would have been alright if I'd reinstalled it. I put a different one on. This has got a brand new 220 nanofarad. Yeah, look at that. Perfect. Crystal clear. Colours are great. I am over the moon. So yeah, very surprising. I am shocked. I'm absolutely shocked. So that's great news because I can now reassemble it and start to use it. And you can just about see the size difference here. Can you see it's a little bit bigger than these? It stands up a little bit higher. But that is a brand new 220 nanofarad cap, and that has solved my problem. So there you go. If you're getting colour problems on these, it might not necessarily be the DAC or LISA or the clamping network or some of the the resistors and things that lead to the output. And attenuate the signal, or terminate the signal I should say. It could literally be these coupling caps that go to the encoder. And there we go, booted back to Workbench. You can see the colours look totally normal. The bars along the top here are white, not pink. Fantastic. So final look at the board now. You can see we cleaned that up earlier. We just swapped that cap there, but the remainder of the board looks absolutely pristine on both sides. And a quick look at the caps there as well, so no issues at all. Oh, I need to get that housing back on there. I'll do that in a minute. I'll get it in the shield first. Anyway, it's looking much cleaner, and obviously it's working perfectly. So I've not bored you with a complete reassembly. I've got that hood back on there, as you can see. I need to carefully get this in, and it's kind of curled on its left hand side, that flex ribbon. It's it's had damage in the past. God, it's blooming hard trying to see what you're doing and try and hold this blooming thing up. And if we push it in, right, it's in, hold it down, and then push the hood down. So hopefully my keyboard is alright. We'll boot syscheck, just make sure. So I booted up okay from floppy drive, that's a good sign. I didn't service the drive, it's been serviced in the past, just to give it a quick clean. I did get some contact clearing to the switches though, because I did find on a prior occasion it didn't detect a disk change. I had to keep sticking the disk in and out, and then eventually it worked. So yeah, you can see keyboard's okay, so I've got away on that occasion. The more times you take these apart and put them back together, the less chance of the keyboard working. So we're all back together. I'll give it a bit of a wipe in a minute, but can you see these labels here? I'm just going to change these labels. That says 26 megahertz. Actually, it runs at 33 now. And when you move to that position there, it drops to 22. So I've got a label for that there. I'm going to remove these three here. You can see you've got three positions there in the middle. There's no compact flash, and then you can have CF0 or CF1. So yeah, replace those labels. And there we go, you can see those labels now, so it's obvious which way is 33 and which way is 22, and likewise you can tell which way to set it for which setting on the IDE there. These covers are replaceable anyway. It's probably the most least intrusive way you could do a mod like this. Well, it's not. The better way is something that's like a soft mod, where you hold a key combination down or something to switch things over. There are little PCBs out there that you can get that will do that sort of thing. Lothrak's got some actually for the Atari range of products. So later in the day here now, I just need to wipe over it. There's the odd little dirt mark there, look, but can you see it's not quite as yellow as it was. Now at different times of day it'll look different on camera and stuff, but trust me, it's a few shades lighter than it was just from being out on a really bright day today, super sunny, and you could have got tan. Yeah, everything's working. Caps lock's not really bright. The hard disk LED is always on this, so I might revisit that. It's the compact flash adapter that's in there. I think it's perhaps the way it's wired. It could even be the compact flash cards I'm using. But you can see the colours are totally normal now. If I quit out of that, you'll see, look at the desktop now. Hopefully you can see the difference. I'll perhaps put a before and after, or a shot and a shot here, just so you can see what it did look like. But this was not grey, it was kind of like pink. There was a pink tinge to everything. So very pleased. It's got nice new polymer caps. The board is nice and clean and tidy. So I didn't show you all of the things I actually did check, but we'll just talk about some of them now. And then hopefully, this summary here might help you if you've got an RGB problem on your 1200. Now we are covering old ground again, recent old ground actually, because we did the same things on one of the 4000 boards in the 32-bit Amiga Repair-a-thon series, and on the a couple of the 1200s within that series as well. Although the fault was in a different area, as you'll see. So yeah, there's the comp pin. It was about 3.5 volts, you should measure on there. The VREF pin is here, and you should get 1.2 volts on there, and we did. Those were okay. And then obviously you can check you've got ground coming into the reference Y. There's FS adjuster, there should be a resistor there that leads to ground ultimately. So they're easy to check, those few connections there. And again, mentioned this before, you've got 8 pins for red, 8 for green, 8 for blue. Those might not be the order. I can see them here. Yeah, R, G, B. Yeah, 8 for each. So it is important that you measure connectivity between Lisa and your DAC here across there, and you won't get a straight short. So you can see you've got 68 ohm resistors in between each of the connections. So if you find the relevant pin, you can't see the pin numbers here, it's so small, find the relevant pin on Lisa and measure across to the video DAC. You could use Amiga PCB Explorer to support that. It makes it much easier. You can hover over the pins until you find the red, green and blue pins around Lisa and highlight them, I don't know, 8 pins at a time, and then just trace them that way using Amiga PCB Explorer. And just make sure you've got 68 ohms in between each of the connections there. That's all good. And of course, if you're trying to rule out a DAC issue, you may need to then scope these things or use a logic probe. If you found, say, a stuck high on one of the red bits, for example, you've got a red problem here, that might indicate there is a problem with red. It's useful at that point using some test software to change what's on the screen. So diagram, for example, I think in there you might have like a red, green, blue test screen somewhere. I'm not so sure actually. I think it shows colour bars, doesn't it? But certainly some of the diagnostic stuff out there, maybe like a test kit for example, you'll be able to get a red screen up and then a green screen and then a blue screen or a black screen or a white screen. So you can eliminate red by just having a green screen and see if any of your red bits are showing any activity. If you saw 1 pin high there on red when you're displaying a solid green screen, that may indicate a problem with Lisa. If everything looks like it's okay coming across here and you're still getting a colour problem, you've ruled out some of the things I'm going to talk about next, then it could be your video DAC. And of course that's the next thing to scope. Once you've got a green screen up, you could look at the analog red, green and blue signals coming out of here. If on the red one here you're seeing some activity, yeah, you shouldn't really have very much activity there if you've got a green screen, so that could indicate that it is the video DAC. You've got the clamping network here that I mentioned, so you've got ground down here going to the anode of each of 3 different diodes, and then each diode goes to the signal, the red, the green or the blue, and then on the other side of each of these signals you've got another diode up here, from its anode, and the cathode goes through to the video supply rail. I forget what that is. It might be 5 volts. I think it is actually. And then we've not seen this fault here with these resistors on my channel, but I do remember one of Retro Game Mod's videos, he had a fault with these here. So your red, green and blue signals come across here. This is where they go out to the SCART cable. If I look at the red there, for example, it's 24.9 ohm resistor in series to attenuate there, and it's the same with the green, the same with the blue, roughly 25 ohm resistors in series. So again, you could measure from the DAC over there to the other side of this resistor and just make sure you've got 25 ohms, 24.9, but there's also 3 pull downs here, actually termination resistors, and these are 49.9 ohms. So again, you can measure between ground and here, and you should see almost 50 ohms on each of those. And all that stuff, as I say, I checked. Now, I didn't capture it, but one of the things I also did was I swapped from RGB, that was where I was getting that pink tinge on the RGB, to composite. And the composite, when it boots, and I mentioned this, but I didn't show it, I wish I'd filmed it, I'm kicking myself. When the screen's like a dark grey or black at the start, before it comes up with the purple sort of coloured Kickstart 3.1 screen, that black screen there was like a shade of pink. There's like a pink tinge to it. It was very noticeable, more noticeable than it was with the RGB. And this is what made me think, oh, hang on a minute, maybe something's going on the way to the encoder. Or the encoder's got a fault and it's somehow causing a problem. It's unlikely because the signal's AC coupled here, so if there was a fault on here, it's unlikely that it would back translate to affecting the RGB. I've just widened the shot there just so you can see, your red, green and blue come out of the DAC here, and they not only go to the analog RGB connections which go to SCART, but each of them comes down here, it's coupled, AC coupled through capacitor 0.22 microfarad, 220 nanofarad, through to the encoder, red, green and blue. And it was the one on the red. That was where we had that resistance of roughly 8k, wasn't it? And then we removed it and I measured it, it was normal. I think the heat was the issue there. You heat ceramic caps up, they can break, or in this case it seemed to miraculously start working again. But I swapped it. I didn't try it with that cap after that point. I just put a new one on and the problem went away. So I am pretty sure it was the coupling cap there for the red. Yeah, the case has seen better days, hasn't it? It is a little bit yellowed, but you know what? It's my Amiga. I am not fussed. Seriously, not fussed. I love it. Anyway, I do hope you found the video interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.